Hello, everybody, and welcome back. Welcome back. We're on question number 17 of the 2003 Grade 11 Fermat paper. In the diagram, triangle ABC is right-angled at C. If BD is equal to 2x and DC is equal to x, and angle ADC is twice angle ABC, then the length of AB is... Okay. What can we do here? Well, I'm going to redraw the diagram so that I can scuff it up and I can add the fact that these angles are doubled. A right angle here. I think D was here, AB, and it was right angled at C, so we've got to have the right picture. So we got 2x here and x here, mindful of the fact that BC now must be 3x. So I'll just add that in. And let's call this angle theta. So we're told that this is twice theta. Theta, of course, being the standard name for a variable representing an angle. Okay, what can we do? I'm not missing any other information, right? No. Okay. Well, we've got angles and right angle triangles, so the first thing I'm thinking is trigonometry, more specifically SOHCAHTOA. Okay? That's just the first thing that's jumping in my mind. I might not have enough information here to use all that. But, well, if we go back and take a look, we've got these thetas here. So let's call the length that we want AB, let's call that Z, and we'll call this height over here the ACY. So now I have two right angle triangles, both of them involving some X's and some Y's. Okay. Oh, maybe I don't need trig. Let me just think for a second here. If this angle here is theta and this is 2 theta, you'll notice that this angle is exterior to this triangle. So that tells me that this must be 2x because we've got an isosceles triangle. Now I can solve for y and then solve for z. Okay, so y squared is, just rearranging Pythagoras here, 2x squared minus the x squared here. And that's 4x squared minus x squared. Y squared is 3x squared. Z squared is 3x all squared plus y squared. And I know what y squared is. So 9x squared plus 3y squared should have 12x squared. So now z is the square root of 12x squared. Square roots distribute over multiplication. So we get square root of 12, which is 2 root 3 times x. So that should be our hypotenuse here. And there we go, that would be C. Now I had the thought to use trigonometry, so I will do it again, but I'm going to see if I can use trig. So I'm going to flip the page, redraw my picture, and see if my trigonometry instinct would have worked out. I liked how quick that one worked. Would the trigonometry have been even faster? So we had 2 theta, we had theta. We had 3x for the whole thing, and 2x here, and 2x here. And I had just given the names z and y. Okay. So, trigonometry with the big triangle, I know that, just using SOHCAHTOA, that these angles, this 3x and this x are adjacent. So I know that cos theta is going to be 3x over z. And I know that cos of 2 theta is, Okay, so I can't use, because there's nothing with Z here. Okay, well, so I would have needed at least another piece of information. So let's add that in, and that leads us to the 2x here. So that would have been x over 2x, adjacent, this x down here, over hypotenuse of this triangle, which would be 2x, and of course that's 1/2. So then cos 2 theta is 1/2, and we all know that cosine of, which thing does that? Cosine of 60 degrees equals 1/2. So 2 theta must be 60 degrees. Theta must be 30 degrees. So I know that cos theta is 3x over z, but that's the same as cos 30 degrees. And cosine of 30 degrees is root 3 over 2. So root 3 over 2 is the same as 3x over z. Now if we do a little cross multiplication, we'll get root 3z, the same as 6x. Z is 6x over root 3. So that should be 2 root 3x. So that also would have worked, but it still relied on this fact. And once I see that I can get this length right here, I'm more inclined to do Pythagoras. That's just, that's my go-to. But of course, trig does work, and maybe there's a way we could have even used tangents and used y instead of having to work out that 2x there. But, you know, not that bad, I would say. Not a whole lot else to comment on for this question. I like that there were two ways to do it, I guess. But both of them did require me to work out AD in the meantime. So we look ahead, and we've got question 18 coming up. So feel free to give that one a try before you jump to the next video. And if you're liking the 2003 Fermat so far, by all means, feel free to subscribe.